The next type of reactions we want to look at are what are known as oxidation-reduction reactions. Before we can get into the four types of oxidation-reduction reactions, let's define these terms, oxidation and reduction. Oxidation-reduction reactions involve the transfer of electrons. Anytime, remember our four driving forces, the formation of a solid, formation of a gas, transfer of electrons, and formation of water. These are driven by the transfer of electrons. Usually, one or more electrons is being transferred from the metal, the cation, to the nonmetal, which becomes an anion. Now, when we think of oxidation reduction, these terms are easy to confuse, so let's pay really close attention to the two definitions. Oxidation is when a substance loses an electron. Reduction is when a substance gains an electron. Now, that seems counterintuitive, reduction being gaining. We will see second semester, when we look at oxidation reduction in a lot more detail, where the term actually comes from. But for right now, oxidation means losing an electron, reduction means gaining an electron. There's a mnemonic to help you memorize that. Leo, grr. Think of Leo the lion saying grr. Leo, loss, electron, oxidation. Grr, gain, electron, reduction. So oxidation, loss electron. Reduction, gain electron. Easy way to memorize these two definitions. Leo, grr. Think about the lion. So let's look at the example of what's happening in some basic oxidation reduction reactions. Think about our substances here. This sodium has no charge. It's by itself. Iron is +2. Chlorine's -1. Sodium's +1. Chlorine's -1. Iron is 0. So sodium is going from 0 to +1. To go from 0 to +1, it must lose an electron. So sodium is oxidized. Iron is going from +2 to 0. So it gained 2 electrons. Remember, electrons are negative, so gaining an electron means you go from a positive to 0 or get more negative. So iron is reduced. I'd like you to pause the video for a second and try these last two, and then press play again and see my answer. Okay, silver here, +1. Nitrate we know is -1. Copper by itself is neutral. Copper here is +1. Nitrate's -1. Silver is neutral. So silver is going from 0 +1 to 0, which means it gained an electron. So silver is reduced. Copper is going from 0 to +1. So copper lost an electron and is oxidized. Magnesium here is neutral. Hydrogen +1, chlorine -1. Magnesium in the compound +2, chlorine -1. By itself, hydrogen is neutral. Any element by itself is going to, without a charge listed, is going to be neutral. So magnesium goes from 0 to +2, which means it lost 2 electrons. So magnesium is oxidized. Hydrogen gained an electron, so hydrogen is reduced. Now, to think about oxidation and reduction type reactions, there's actually 4 categories that are oxidation reduction reactions. For all 4 of these categories, they would be their individual category, and they would also be oxidation reduction reactions. The first one is synthesis. Synthesis, or sometimes called composition, meaning putting things together. Here's an example. Hydrogen and oxygen coming together to form water. It's always building something from its pieces. The next one is combustion. Combustion is burning anything. Burning always involves a large amount of heat. It's always the reaction of something with oxygen, and both products will contain oxygen. This is the common form. A hydrocarbon, carbon-hydrogen compound, reacts with oxygen to form carbon dioxide and water. Now, water may be a bit confusing to people because how is water given off when something burns? But remember, this is water as a gas. It's not a liquid. You're not going to get a puddle of water in the flame. It's a water vapor, the steam. Next one is decomposition. Decomposition is the opposite of synthesis. You are breaking something down to form two or more individual elements or compounds. The last one is single replacement. This is kind of like double replacement that we saw earlier with precipitation and acid-base. Here, one element is replacing another element, not both being replaced. So you always have an element reacting with a compound, and the products are always a compound and a new element. Two things can be replaced. Either metal replaces metal, or halogen replaces halogens. Sorry, there's a typo there. Now, with single replacement reactions, we have to use an activity series. Only things higher on the chart can replace things lower on the chart. So lithium can replace any other metal. Fluorine can replace any other halogen. This side, the halogens, follows the periodic table exactly. If you look at the periodic table, it goes straight down the periodic table. Fluorine is the most reactive, will replace anything else. Iodine will not replace any of the other halogens. The metal series doesn't fit a nice pattern on the periodic table, so it's actually given to you on the back of those blue periodic tables in the classroom. Anything higher on the list will replace anything lower. So gold won't replace anything. Lithium will replace everything. So these are our four remaining types of reactions: our oxidation-reduction reactions, synthesis, decomposition, combustion, and single replacement.